Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we're going to be looking at previous year questions of mathematics asked in engineering exams in India. Today we're dealing with another very important topic. The topic is complex numbers. So these are numbers with both real and imaginary parts. Today we're going to be looking at some questions regarding complex numbers and how we are supposed to solve them. Here comes our first question. If modulus of z minus 4 is less than modulus of z minus 2, its solution is given by. So we need to find which of the values of the real part of z is correct for this question asked in 2002. So how do we solve this question? First, we'll consider z to be a complex number of the form a plus ib. So therefore, the equation modulus of z minus 4 less than modulus of z minus 2 can be written as modulus of a minus 4 plus ib less than modulus of a minus 2 plus ib. So this is now our equation, and we would now need to use the formula for modulus of a complex number. So the modulus of a complex number a plus ib, mod a plus ib, can be written as a square plus b square, because it will be the number itself times the conjugate, so you get a square minus b square on the left hand side. On the right hand side. So taking that property here, the real part encompasses a minus 4, and over here it's a minus 2, so you'll be writing a minus 4 the whole square plus b square less than a minus 2 the whole square plus b square. So you can write a square plus 16 minus 8a plus b square is less than a square plus 4 minus 4a plus b square. So over here we will take the terms with a on one side and all the other terms on the other side. So basically minus 8a plus 4a is less than a square minus a square plus b square minus b square. So both of them will become 0 anyways. And then minus 16 plus 4. So we'll write these two as 0, so they get out of the picture. Minus 8 plus 4 is minus 4a. It is less than minus 12. Since both sides are negative, we can remove that. But when we're removing the negative sign, the less than symbol becomes greater than, so 4a will be greater than 12. And it makes sense, because if 4a is greater than 12, if you were to take negative 4a, it would be less than negative 12, because in negative numbers, the bigger the value of the negative number, the lesser it is. So that relation is true. So 4a is less than 12, so a is less than 12 by 4, which means that a is less than 3. And over here, a goes for the real component of z. So the real component of z is less than 3. So if you were to look at the answer to this question asked in 2002, the correct option would be option C. Real of z is greater than 3. And we use that by taking the complex number z as in its standard form, that is real of z plus imaginary of z, and then removing the imaginary part and finding out just the real part with that inequality. So option C is the correct option. Let's look at the next question. If 1 plus I divided by 1 minus I the whole raised to x is equal to 1, then which of these is the correct value for x? So how do we solve this question? So from this equation, whenever you have division with a complex number, it is important to take the conjugate of the denominator and then multiply both the numerator and the denominator by that conjugate. So over here, the denominator is 1 minus I, so the conjugate of 1 minus I is 1 plus I. So 1 will be equal to 1 plus I times 1 plus I divided by 1 minus I times 1 plus I. All of that is raised to the power x. So you get 1 plus I the whole square on the numerator, and then on the denominator you will get 1 squared minus I squared, all of that raised to x. So 1 plus I the whole square can be written as 1 squared, that is 1, plus I squared, that is minus 1, and then plus 2 times 1 times I, so that's 2I. Divided by the denominator will be 1 square, that is 1, minus of I squared, so that is minus of minus 1, so that's plus 1, the whole raised to x. So basically it's 2I divided by 2, the whole raised to x, which means the value of 1 is I raised to x. Now in complex numbers, you would have known that the value of I is under root of negative 1. So therefore the value of I squared will be negative 1. I cubed will be I times I squared. So basically minus 1 times I. So that's minus I. And then I raised to 4 will be I squared the whole square. So that's minus 1 the whole square, which is equal to 1. So basically, if you have I raised to any integer multiplied by 4, then you will get the value as 1. So I raised to x will be equal to I raised to 4n. So therefore the value of x will be equal to 4n. If you were to look at our question, then you would notice that option D will be the correct option. So x equals 4n, where n is any positive integer. Let's look at this question. Z and omega are two non-zero complex numbers such that modulus of z equals modulus of omega and argument of z plus argument of omega equals pi. Then find the value of z with respect to omega. Is it omega complement, minus omega complement, omega, or minus omega? So in order to solve this question, we have to consider modulus of z equals modulus of omega equal to some constant r. And then we will consider alpha as argument of z and beta as argument of omega. So since argument of z plus argument of omega equals pi, you can write alpha plus beta as equal to pi, an important relation we will use later in this question. So now, since modulus of z equals r and modulus of omega equals r, you can write the value of a complex number z as equal to its modulus times e raised to I times its argument. So in the case of z, that will be r e raised to I alpha. Similarly, you can write omega as equal to r e raised to I beta. So now that we know these two equations, we need to find z with respect to omega. So we will go back to the equation z equals r e raised to I alpha. Now, since alpha plus beta equals pi, you can write alpha as equal to pi minus beta. So therefore, z will be equal to r e raised to I times pi minus beta. So it'll be r times e raised to I pi times e raised to minus I beta. So e raised to I pi is equal to, 1. and r is a constant here, so therefore it will be minus r times e raised to I beta on the right hand side. And r e raised to I beta will be equal to omega, so the value of z will be equal to minus omega. So therefore, the correct option among the following is option D, minus omega, for this question asked in 2002. Let's look at the next question. If z equals x minus iy and the cube root of z is given as p plus iq, then you need to find the value of x by p plus y by q whole divided by p squared plus q squared. So how do we solve this question? We will use the second given relation. So cube root of z is p plus iq. Taking cube on both sides, the value of z will be equal to p plus iq the whole cube. Now that will be equal to p cube plus iq the whole cube plus 3 p squared times iq plus 3 p times iq squared. This is using the formula of a plus b cubed. Okay, so basically you will write the value of z as p cube plus I cube times q cube plus 3p squared q times I plus 3p q squared times I squared. So now we will put in the values of I cube and I square in this equation. So I cube is basically minus I, so it'll be p cube minus iq cube. Then you have 3p squared qi plus, instead of plus it should be minus because I squared equals minus 1, so it'll be minus 3pq squared. So now what we're going to do is we're going to take the terms, the real terms on one side and the imaginary terms on the other side. So here the real terms are p cube minus 3pq squared, and then you have 3p squared qi minus iq cube. So when you take I out of it, you get 3 squared minus pq squared minus 3pq squared as the real terms, and then you have I times 3p squared q minus q cube as the imaginary term. So this is x and this is y because the value of z is given as x minus iy. So we can write x as p cube minus 3pq squared, which can be written as p times p squared minus 3q squared. So therefore x by p will be equal to p squared minus 3q squared. Similarly, we can write y as equal to minus of 3p squared q minus q cube, because here the equation is x minus iy, so minus y will be equal to 3p squared q minus q cube. Just put the minus on the right hand side and you get the value of y. So what you can do is you can take q outside, so it'll be minus q times 3p squared minus q squared. This is the value of y. So therefore you can write y by q as equal to minus of 3p squared minus q squared. Now we add x by p and y by q. So x by p plus y by q will be equal to p squared minus 3q squared minus of 3p squared minus q squared. We can write that as p squared minus 3q squared minus 3p squared plus q squared. P squared minus 3p squared is minus 2p squared. Minus 3q squared plus q squared will be equal to minus 2q squared. So x by p plus y by q will be equal to minus 2 times p squared plus q squared. And in order to get the term in our question, you can write x by p plus y by q divided by p squared plus q squared. So basically keeping it to the left hand side, you will get the right hand side as equal to minus 2. So if you were to look at our options, you would see that option D is the correct option. So what we essentially did was we took z, the cube root of z, and then cubed it, so the left hand side becomes z, and the right hand side will be in terms of p and p plus iq cubed. And then after getting the real and imaginary terms, we equate them, and then we find x by p and y by q. So x by p plus y by q will be written as minus 2 times p squared plus q squared. So p squared plus q squared is taken to the left hand side. So you get the final answer as minus 2 for this question asked in 2004. Moving on to the final question of this episode. So if z squared minus 1 the whole modulus equals modulus of z the whole squared plus 1, then where does z lie on? Whether it lies in a circle, the imaginary axis, the real axis, or an ellipse. So first of all, modulus of z squared minus 1 equals modulus of z the whole squared plus 1. Now what we do is we take z as equal to x plus iy. So therefore you will write x minus 1 the whole squared plus y squared as equal to x squared plus y squared plus 1. So basically, what happened is that we just used the formula for the modulus. So since 1 is a real term, it goes with x, so it becomes x minus 1 the whole square. So now what we can do is we can expand x minus 1 the whole square, so that's x squared plus 1 plus y squared minus 2x. Actually, instead of minus 2x, it'll be plus 2x because it's minus 2 times minus 1 times x, so that's plus 2x. On the right hand side, you'll have x squared plus y squared plus 1. So we'll take all of this to the right hand side, so you have 2x as equal to x squared minus x squared plus y squared minus y squared plus 1 minus 1. So 2x will be equal to 0, so that means x is equal to 0. Now remember, x is the real part of z. So if the real part of z is 0, then the complex number z must lie on the imaginary axis. So the correct option here is option B, the imaginary axis. So why we know it's the imaginary axis? Because the real part of z, that is x, is given out to be 0. And we did that by using the formula for modulus. Modulus of z will be equal to x squared plus y squared if z is equal to x plus iy. So now we have reached the end of this episode. So again, the answer is the imaginary axis because the real part of z is 0. So we've reached the end of this episode. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.